everyone. In today's video, we are going to cover exponents and multiplication. Our learning targets for today are I can write products using exponents, I can evaluate expressions involving powers, I can find products of powers that have the same base, and I can find powers of powers. First, looking at what is an exponent, if we look at this example here, the number a is what we call the base, and the number n is what we call the exponent. So the expression an is called a power and is read a to the nth power. Now, if I look at this in terms of numbers, I have 8 to the third power here. 8 is my base number, and 3 is my exponent. The exponent tells me how many times to write the base number. So 8 to the third would mean 8 times 8 times 8. Now, if we look at a couple of these as examples, we want to write each expression using an exponent. So I have 2 times 2 times 2. So I want to write this in standard form. This is called expanded form. I want to write it in standard form. So my base is 2, and I wrote the 2 3 times, so it's 2 to the third power. Number 2, I have x, 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 so there's 4 x's there. My base is x, x to the fourth. Number 3, I have 2 threes, 3 x's, and 4 y's. So I'd have 3 squared, x to the third, and y to the fourth. Now I want to reverse it. I want to write each expression without using the exponent. So I have 4 to the third power. This would be 4 times 4 times 4. X to the fifth, y to the third would be x times x times x times x times x times y times y times y. And 7 to the third, a to the sixth, b to the fifth would be 3 sevens, would be 6 a's, and 5 b's. Now looking at simplifying exponential expressions. So an exponential expression is completely simplified if there are no negative exponents, the same base does not appear more than once in a product or quotient, no powers are raised to powers, no products are raised to powers, no quotients are raised to powers, and numeral coefficients in a quotient do not have any common factor other than 1. So we have some examples to the left that would be completely simplified, and some non-examples to the right that are not simplified. Whenever we do these problems, we want to have them completely simplified, so we need to follow these rules. First, we'll look at exponents and multiplication, specifically the product of powers property. Now, the product of powers property happens when we multiply like bases. So when like bases are being multiplied, their exponents can be added. So in other words, if we have x to the a power times x to the b power, this is going to be equal to x to the a plus b. This is our rule or our trick when we have multiplication of like bases. We need to be careful and remember a number or variable written without an exponent actually has an exponent of 1. So the number 10 is actually 10 to the first power, and the variable y is actually y to the first power. If we look at this first example here, I have 3 squared times 3 to the fifth. If I apply my rule, I would just add their exponents since I have like bases, because 3 squared is 3 times 3, and then I want to multiply that by 3 to the fifth, which is 3 times 3 times 3 times 3 times 3. If I count how many 3's there are 7. If I rewrote this back in standard notation, I'd have 3 to the seventh. So an easier way to do this quickly is just to add the 2 and the 5 to get me 3 to the seventh. Looking at a few of these examples, I want to simplify each expression using the product of powers property. My first one, I have 2 to the fourth times 2 squared. So the 2, the base is going to stay the same, and then I'm going to add the exponents. So I'd have 2 to the sixth. Looking at number 2, 6 to the fifth times 6 to the fourth. Again, my base stays the same. I'm going to add the 5 and the 4. 5 plus 4 is 9, so I have 6 to the ninth. Number 3, I have 3 squared times 3 to the sixth. Here I have 3, so I'm just going to do 2 and then do the third one. 3 squared times 3 would be 3 to the third, because remember that 3 is 3 to the first, and then 3 to the third times 3 to the sixth is 3 to the ninth. Number 4, now I have 2 different bases. I can only combine like bases, so I'll combine the 9's and then the 5's. 9 squared times 9 to the seventh would be 9 to the ninth, and then this is going to be multiplied by 5 to the first times 5 cubed, which is 5 to the fourth. Looking at number 5, now we have variables. Again, the variable is just acting as a base. So x to the third times x to the seventh, my base will stay the same, so I have x, and then 3 plus 7 is 10. Y squared times y would be y to the third. W cubed times w to the fifth times w1 is 3 plus 5 plus 1, which is w to the ninth. z9 times r squared times z times r to the fourth. Again, I would have z and r as my bases. So z9 and z1 would combine to z10. R squared r4 would be r6. Now, number 9, I have a coefficient out in front of my bases. This is a multiplication problem, so with the coefficients, I'm just going to multiply them. So 6 times 2 would give me 12. And then with the bases, I'm going to add their exponents. So 6x squared times 2x cubed is 12x to the fifth. Number 10, we have negative 5y to the fourth times 2y. Again, I'm going to multiply the coefficients, so negative 5 times 2 is negative 10. And then I'm going to add their exponents because they both have a base of y. So y to the fourth times y to the first is y to the fifth. Looking at number 11, we have negative 4w squared times x to the fifth times 8w. Notice I have like terms of w squared and w. I don't have a like term with the x, so I'll leave that separate. So negative 4w squared times 8w would give me negative 32w to the third, and then I'd have my x to the fifth left over. And my last one, we have 7w squared x to the fifth times 3w squared x to the seventh. I'll combine the 7 and the 3. 7 times 3, because they're coefficients and this is a multiplication problem, is 21. W squared times w squared would be w to the fourth, because I'll add their exponents, and x to the fifth times x to the seventh is x to the 12th. Looking at our next property, we have power of a power property. So a power to a power. When an exponent is raised to another exponent, the exponents can be multiplied. In other words, if we have x to the a to the b power, we would have x to the a times b. Looking at this in an example, if we have 5 squared to the fourth power, this 4 tells me to multiply the 5 squared 4 times. So 5 squared times 5 squared times 5 squared times 5 squared. Notice I have 2, 4, 6, 8, which is 2 times 4. So 5 squared to the fourth is 5 to the eighth. Looking at a few more examples, we're going to simplify the expression using the power to a power property. So here, first one, we have 4 cubed to the third power. This is telling me 4 cubed times 4 cubed times 4 cubed. So I'm going to keep my base the same of 4, and then 3 times 3 is 9. So 4 cubed to the third is 4 to the ninth. 6 squared to the fifth, I'm going to keep the base the same of 6. 2 times 5 is 10. So we have 6 to the 10th. 9 squared to the fourth would be 9 to the eighth. 5 to the fourth to the eighth would be 5. 4 times 8 is 32, so 5 to the 32. Now with variables, again, nothing's going to change. My variable is the base. X squared to the sixth power would be x to the 12th. Y to the fourth squared would be y to the eighth. Z cubed to the ninth would be z to the 27th. R to the fifth to the 11th would be r to the 55th. Now looking at number 9, we have 4x to the fourth squared. Now I have two bases, a base of 4 and a base of x to the fourth. Remember, any number without an exponent actually has an exponent of 1. So I need to bring the 2 to the 4 as well as to the x. So I'd have 4 squared and then x to the fourth squared, which would be x to the eighth. I could simplify this further by saying 4 squared is 16, so I could say 16 x to the eighth. Number 10, we have 6y9 to the fourth power. Again, I want to bring this 4 to the 6 and the 9. So 6 to the fourth, y to the 9 times 4, which is 36. 11, we have 2z squared x to the third to the eighth power. I'm going to bring the 8 to every single base. So the 2, the z, and the x. 2 to the eighth. Z squared to the eighth would be z to the 16th. X cubed to the eighth would be x to the 24th. And my last one, we have 2r to the fifth to the third power times 3r to the third squared. I want to do the power of a power first, and then I will multiply them together. So 2r to the fifth to the third would be 2 cubed r to the 15th. 2 cubed is 8 r to the 15th, so I'll leave that as 8 r to the 15th, times 3 r to the third squared. 3 squared is 9. R to the third squared would be r to the sixth. Now I can combine these. 8 times 9 would be 72, and then r to the 15th times r to the sixth would be r to the 21st.